Welcome and congratulations to making it to the summary video through the course. I hope you've worked through the course and kind of have a good idea of exactly everything you need to know to be able to graph a linear equation using slope-intercept form. What I'd like to do is just kind of go over some of the common tips and tricks that I think that I use throughout this course, as well as that I think might be helpful for you to kind of remember, as well as kind of some common mistakes that I might have mentioned in some of my videos, just to kind of give you that overview of exactly what we did. So first of all, if you remember, what I'd like to first go through is kind of like the process and summarize. So we're provided either some information or an equation. The first thing we want to do is make sure we write that in slope-intercept form. Sometimes we might have equations that are not in that format, or even in the information to put it into that form. The next thing we want to do is identify the slope and the y-intercept. Then we want to plot the y-intercept and then use the slope to move from the y-intercept to the next point using the change in y over the change of x as the slope. And then we connect those 2 points and extend both ways. So let's kind of start in talking with some tips and tricks that I've used. As I've talked about, when we're looking into the slope, sometimes we'll have slope as a whole number, and sometimes we'll have it in as a fraction. So it's very, very important to always make sure you write your slope as a fraction. Because that is so essential when we're thinking about slope. Remember, slope is a ratio. It's a rate of change. The change in your y-coordinates over the change in the x-coordinates. So if you just have it as a whole number, sometimes it can get confusing of understanding what is that the change of the y, or the x. So always rewrite it as a fraction. And just an example, remember, if I have 4 as my slope, I can rewrite that as 4 over 1. Therefore, I can say the change in my y-coordinates is 4, and the change in my x-coordinates is 1. The next thing is rewrite the y-intercept as a point. We know that the y-intercept is b, but remember the y-intercept is a coordinate point 0, b. We can say that yes, y equals b. That's where the graph is going to cross the y-axis. But I think it's very helpful to understand that when you write it as a point, you understand that the x value is always going to be 0, meaning the point is always going to lie on the y-intercept. The next thing is label my points. I don't think label my points. Oh, I think that was just going through when you're starting up, when you have something, let's say it's y equals 3x minus 5. Label what you're talking about. Don't confuse the slope and the y-intercept. That is my slope. That is my y-intercept. Right? So make sure you connect them. And also make sure when you have like a minus, make sure that is, that that's a negative 5. All right? That's actually a common mistake that I see with students that I just remembered. So when you're provided a problem, make sure you label what the slope is and what the y-intercept is. Now let's go and look over some common mistakes. Some common mistakes that I see from students is they plot the y-intercept and then they do the slope, but they do the slope from the origin. You got to make sure that when you have your point, remember the point on the y-intercept and your slope, those are going to connect 2 points that are on the line. So if I have an equation, and let's say here's my y-intercept, you're going to use your slope triangle from that y-intercept, not from the origin. I see a lot of students, they'll plot the y-intercept, and then they do their slope triangle from the origin and then connect. You got to go make sure you go from the y-intercept. The next thing is negative slope. This one gets a lot of students, especially if I had like a whole number, negative 4. Remember, that is negative 4 over 1, which we can rewrite as negative 4 over 1, which is the same thing as 4 over negative 1. So all three of those representations are equivalent to each other. And a lot of times, depending on where your y-intercept lies on the graph, you can kind of choose which one of these slopes works best, or use both to kind of have 3 points on the line to help you do that. The next thing would be to extending. I can't even tell you how many times I get students that will go like this, or they'll do that. Remember, a line extends indefinitely in both directions. So we want to make sure we write these arrows on there stating that the line is extending past the 2 points. We only need 2 points to create a line, but a line contains infinite many points. So we're going to use those arrows to extend. And the last step that I just remembered is y equals mx plus b is our standard form of our equation, right? So if I have an equation y equals 3x minus 5, make sure you note that b is equal to negative 5, because the standard form of the equation is plus b. So therefore, if b is negative 5, or I'm sorry, if my equation is negative 5, then my b is negative 5, and my coordinate point is 0, negative 5. So there you go, ladies and gentlemen. That is just a quick summary of how to graph linear equations using slope-intercept form. Thanks.